Okay, now I believe geometry to be one of the best disciplines for you to learn the art of deductive reasoning. Now, what it essentially does is it teaches you how to use the limited amount of information that has been given to you in order to recover the missing piece of a puzzle. Well, kind of sounds like Sherlock Holmes at play here, doesn't it? Well, of course, it's not just going to help you in solving crime better, but it's also going to help you in come up with good legal arguments or just, communicate effectively in the end, apart from, of course, making you better at problem solving and mathematics eventually. Now, guys, what we're going to do in this video is first go through understanding what deductive reasoning is, and then eventually slowly make our way into geometry. And the topic that we're going to be looking at is areas of two-dimensional shapes. Okay, so first start deductive reasoning. Now, as you can see, I've got a few examples laid down here for you, and they're pretty simple, right? I mean, the first one, you can see that I have marked P1 and P2. Now, what these statements basically are is they act like supporting statements based on which the conclusion has been drawn. So we assume that these two statements are true. Of course, all men are mortal, and Socrates happens to be a man. So, based on the evidence or based on what these supporting evidences say, I can make a conclusion that Socrates has to be mortal, since Socrates is a man and all men are mortal. Giving you an example from the perspective of geometry, let's suppose we know that all triangles have three interior angles that add up to 180 degrees, right? Now, right angle triangle, you must be familiar with it. Like, it has one angle which is equal to 90 degrees, right? A little visual may help you better. So this is a right angle triangle. One angle is 90 degrees in it. So therefore, right angle triangles have one angle equal to 90. Yeah, these are the two supporting statements. Now, based on these two, I can make a conclusion that the two remaining angles of all right angle triangles must be acute. Now, what is an acute angle? Acute angle is an angle less than 90. Why do you think this conclusion has to be true? Because then if I'm using these two supporting arguments, now these two angles, let's suppose this is angle X and this is angle Y, angle X and angle Y must together add up to 90 degrees because the remaining 90-degree angle is here, right? So they have to be less than 90, right? Because if one angle is more than 90, it's not going to be a triangle at all. Yeah. Now, let's attack this idea from the perspective of, as I said, it helps you construct good legal arguments, right? So let's check this out. So again, I have two supporting statements. The first premise here goes on to say that an individual may not drive more than 30 kilometers per hour in a school zone. Okay, and then the second premise goes on to say that Socrates was driving at the speed of 40 kilometers per hour in a school zone. Therefore, based on these two premises, the conclusion is that Socrates has violated the law. Now, if let's say you are given the job of defending Socrates, how are you going to construct a better argument? You're obviously going to attack these two premises or supporting arguments based on which the conclusion has been drawn, right? So you can go ahead and say that, let's say I'm looking to attack the first premise here. You could say that maybe the rule does not apply in the case of an emergency. You read through it, or does the rule apply only during the school hours, or is it applicable throughout the day? Or if you're looking to attack the second premise here, maybe Socrates was not driving at the speed of 40 kilometers per hour at all, or maybe the area in which he was driving was not a school zone itself, right? So this has been taken from Seven Sage Law School. So I've listed down the source. So this is how, deductive reasoning comes into play. Okay. Geometry will make you get very better at it. In fact, not just geometry happens to be the best, any form of mathematics, because this is what mathematics is all about, right? I mean, we're given some information, and just based on that information, we got to figure out the unknown, right? Come on. So let's turn our attention towards figuring out areas. Now, I've got four simple shapes here. The first one is a rectangle. Do we know how to figure out the area of the rectangle? Of course we do, right? This, let's suppose, is considered to be the length of the rectangle, and let's just say this is the breadth or the width. How do we figure out the area of the rectangle? Well, simple. The area of the rectangle is going to be the length times width, right? Fairly simple. Now, second one is a square. Now, a square is nothing but a rectangle where the length and the breadth or the width are equal. So this is where your length and breadth are the same. Let's just go ahead and call it some S. So SSS, all the sides are the same. Area is pretty much going to be derived from the same idea, that is side times side. So the area of square is going to be side square. Now, a triangle is essentially a rectangle cut into half. Like if I draw a line here, this shaded part for you is going to be a triangle, right? So what is going to be the area of a triangle? Half the rectangle. So we say, let's say this is the breadth and this happens to be the perpendicular drop. Let's say this is the vertical height of the triangle. The area is going to be, as I said, half the area of rectangle, which is half of length times width. We can write it like half times base times height. And here I've got our favorite circle. This is the radius. Let's just say distance from the center to the circumference. What is the area of the circle going to be? Pi r square, right? So these are a few things that I'm sure you must be knowing: area of rectangle, square, triangle, and circle. Now, based upon these simple ideas, we are going to solve some really good questions. Here's the first question coming your way, and as usual, I would always suggest you to pause the video, take your time, try to solve the problem on your own, and then get back and then let's solve it together later on. Okay, so I hope you have given this a try. This happens to be one of my favorite geometry questions. So let's go through this. So here it says P is a point on the circumference of the circle. So as you can see, P is right here. PA and PB are drawn perpendicular to the x and y axis. You know what perpendicular means, right? It means the base at an angle of 90 degrees. That's what perpendiculars mean. AB is given as 15. All right, so this is AB here. So this is my 15, and we've been asked to find the area of the circle. Okay, so do we know how to find the area of the circle? Yes, we do. What is the area of the circle? Pi r square. So in order for me to figure out the area of the circle, I've got to figure out the radius. If I know the radius, I can find the area. So all our efforts now would be directed towards figuring out the radius. Okay, so what is the radius in this case? I can say this line represents the radius, right? All these lines, these are the radius. But how do I figure these radius? I mean, this is also going to be radius, of course. Yeah. So how am I going to figure out the radius in this case? Because all I know is that AB is equal to 15. Okay, let's think through this. Now, first thing I know is that PA and PB are perpendiculars drawn, right? So this angle has to be 90 degrees. Yeah. Now, if I go ahead and assume that PA is some x and PB is some y, I've got Mr. Pythagoras, right? So applying the Pythagoras theorem, what do I get? I get x square plus y square equals 15 square. Now, if this is PA, then OB also has got to be the same, right? I can make a logical conclusion that OB has to be equal to PA, and then OA has got to be equal to PB. So this also has to be x and this also has to be y. But again, even if after drawing x and y, it's still not helping me figure out the radius, right? So let me just draw the radius with a different color for you here. So let's just stick to the domain. Let's just stick to where our PA, PB, and AB are. Now, this is also going to be radius, isn't it? If I draw it out, wait. This is also what is happening. Okay, some technical glitch. All right, so this is also going to be the radius, isn't it? OP is also going to be radius. So how do I figure out OP? Now, if I look at this part of the triangle, which I'm highlighting in orange, I have the same PA to be X and OA to be Y. So it is also a right angle triangle because remember, we were dropping perpendiculars down. So OP happens to be the radius, right? OP happens to be the radius. And how do I find OP? OP is nothing but x square plus y square equals OP square. Now, x square plus y square we already know is 15 square. So 15 square is OP square, which means the radius OP is, there you go, 15. So all it required from your side was a change of perspective. That's all. And then you got to stick to the right zone where all the variables or the information given to you is. So now that we know the radius, figuring out the area is a child's play for us. So what is the area going to be? Pi times 15 square. I'll leave the calculations up to you, no big deal. So I hope you've understood how you're gonna slowly build upon what is given to you, and how do you connect what is given to you to what is asked. Okay, cool. Let's move on and check out the next question. um, Okay, this is again a good problem. So here this says that there are four cows that have been tethered at each of the four corners of a square of side 14. So this shape that you see here, let's name the vertices A, B, C, D. So A, B, C, D is a square, and we know the side of the square to be 14. And you've got a cow each at one of the four vertices. Sorry, all the four vertices. You have four cows being put there, so that adjacent cows can just reach each other. Fine. So this is an important point, can just reach each other. And then again, there's a small circular pond of area 20 meters square at the center. Okay, so there is a small pond here. The area is 20 meters square. We got to figure out the ungrazed area. Now think of it. If you have a cow here, okay, and then a cow can only reach till this point, let's just say, because there is a cow at D as well, there's a cow at C as well. They're both just going to touch each other, which means this is going to be 7 meters and this is going to be 7 meters, right? If you've understood that part, because the length of the rope has got to be 7 meters. And then the way the cows are going to graze is not going to be some weird shape. It's going to be a good way. Like you have let's just say this, imagine my hand to be kind of like a rope, and then imagine the cow grazing. The cow is going to graze like this, right? It's going to graze like this. So that's the reason why you're going to have this nice shape in which the cow will graze this. Yeah. And then the cow being tied here is also going to graze something like this as well. Yes, this part. And then this cow is also going to graze something like this, and then this cow is also going to graze something like this. So what do you call this shape here which I'm highlighting? This is nothing but quarter of a circle, right? And we know the radius as well. The radius is this part here, which is the length of the rope through which the cow is tied down. So area of quarter of a circle is going to be what? Pi r square over 4. And this cow also is going to graze pi r square over 4. Same, this cow pi r square over 4 and pi r square over 4. So add all of these up. Okay, so what do you get? 4 times pi r square over 4. So the cows are grazing an area that is equal to pi r square. And we know the radius to be 7, right? So if I consider pi to be 22 by 7, just for approximation, so that my answer turns out to be an integer, yeah? So that's 22 by 7 multiplied with 49. So I'm getting 22 times 7, which is 140 plus 14 gives me 154 meter square. So the cows are grazing an area of 154 meter square. We've got to find the ungrazed area. Remember, there's a circular pond as well, 20 meters square. So how do you find the ungrazed area? So simple, right? From the total area of the square, what is going to be the area of square? From the area of the square, I've got to remove 154, the grass that the cows have eaten, and I also got to remove the 20, right? Because the cows are not going to go anywhere near that. So what is the area of the square? Square of the side. So that happens to be what? 14 square minus 154 minus 20. So what is 14 square? 196 minus 154, 164, 174. That will give you how much? 22, I believe. So 22 meters square is the ungrazed area, right? So guys, these are not just any type of questions. Okay, these are good challenging problems, and if you are able to solve them on your own, give yourself a nice pat on the back, or ask your parents to do that for you. Okay, you've done a very good job in case you were able to solve these problems on your own. Okay, so I hope this is understood. Next part, let's move on and check out one last question. Okay, the last question here. And before, okay, let's just first go ahead and understand the problem here. So in the diagram below, PQRS is a rectangle, all right? So it looks like a rectangle as well. Px equals xy equals yq. Okay, so these parts are the same, and we've been asked to find the ratio of area of triangle XYR. So this is the triangle that we're looking at to the area of the rectangle PQRS. Now, there is something amazing whenever the ratio is asked. Now, the ratio of 1 over 2 is equal to the ratio of 2 over 4. This is equal to the ratio of 3 over 6. This is equal to the ratio of 4 over 8. So, a little technique that I'd like to give you whenever the problem is centered around figuring out ratios is you can assume any number. You don't have to take a variable here. Like I don't have to take let px be equal to some x, and x. Take any number, your choice. Like let's suppose I take px to be 10, xy to be 10, yq to be 10 because it's mentioned px and xy and yq are the same. And I can go ahead and take rq to be some number. Let's say, what do you want me to take? 20? Okay, let's just take it to be 20. Great. So now half the job is done. I know what the area of rectangle is. And by the way, you can check this out by taking any number of your choice. We're both going to arrive at the same answer because of this property of ratio. So the area of the rectangle is going to be what? Now all these added up, the complete length is going to be how much? 10 plus 10 plus 10. So that's going to be 30. So that's going to be 30 times 20. So that's 600. So half the job is done. Okay, I know the area of the rectangle PQRS. Now I just got to figure out the area of XYR. Now for that, I've got a little simulation for you. Have a look at this. Because based on this, good questions can be designed. Now, we already know what the area of the triangle is, right? It's half times base times height. Now, okay, let me move this guy around a little bit. Now, all the three angles here are close to being acute, right? Now, if this is a right angle, the area of the triangle is still the same. But look what happens now. If you have one of the angles in the triangle more than 90, like in this case, this angle here where I'm moving this cursor, the perpendicular, you can't drop it inside the triangle. Like if you want me to figure out like the height here, I can't drop a perpendicular inside like this. The perpendicular has to drop outside, right? So based on this property, if I go back to the question, like look at this triangle. Look at this triangle here. What is going to be the area of this triangle? Well, I know the base to be 10. I know the height to be 20. So the area of this is going to be half times 10 times 20. How much is this coming as? 100, right? Now, if you look at this triangle x by r, even the triangle x by r is going to have the same height like I just showed you here. The height is going to lie outside that triangle because height is the perpendicular drop from the vertex to the base. So this triangle is also going to have the same area because the base is the same 10 and the height is the same 20. So I know the area of the triangle x by r to be 100 here, right? This is a very useful property, comes in very handy, and then really good challenging questions are designed based on this. So what are we waiting for? What is the ratio of area of the triangle x by r to the area of rectangle PQRS? It's going to be 100 divided by 600, and there you go. The ratio is going to be 1:6, and I'm sure you'll get the same answer. It doesn't matter what numbers you take. Like you can take px to be 2, xy to be 2, yq to be 2, and then you can take RQ here to be 5, 10, whatever your choice is. We're all going to end up with the same answer. So I hope you had fun in this session solving these three good area-based geometry problems, and then you've understood how geometry builds upon your deductive reasoning skills by giving you some information, and you use that information to figure out the unknown. So that's it from my side. Until next time, take care of yourself. Bye-bye.